Hi everyone and welcome to Python for Beginners. Today we are talking about list comprehensions. I want to show you the basics of list comprehension and how the setup looks. Then I want to compare it in a basic example to a for loop. As the video goes on, we are going through multiple examples from beginner to more advanced. Therefore, I always show the matching for loop first and then how to treat it with a list comprehension. First of all, some general information. List comprehension are a powerful and consistent way to create new lists based on existing iterables like lists, strings or tuples in Python. They provide a one-line alternative to using traditional for loops, making your code more readable and efficient in many cases. Let's get into it. Here you can see the general setup of a list comprehension. You need to create a new variable and then you can add an expression. This is what you want to do with each item in the iterable. This can be a simple variable, a calculation, a function call, or even another list comprehension. Next is the item. This represents each item in the iterable as you loop through it. You can give it any name you like. After that you add the iterable. This is the list, the string, the tuple or any other sequence you want to create a new list from. And at the end you can add a condition. This is an optional filtering step. If you include it, only items that meet the condition will be included in the new list. These four inputs go into an opening and closing square bracket to create a new list. That is why it's called list comprehension. So let me comment this out to prevent errors and let's see this in action. Every list comprehension can also be represented by a for loop. That's why I start with the for loop in which I want to square a list of numbers. After that I show you how the same code would look in a list comprehension. As list we can iterate through, we create a list with numbers from 1 to 5. Then for the loop we create an empty list called squared numbers. And then we can start looping through by running the code for number in all items of the numbers list. Inside the loop, we then multiply the number by the number and append it to the squared number list. In other words, we multiply 1 by 1, then 2 by 2, then 3 by 3, and so on. This is the expression we saw earlier. In each step, we add the result to the empty squared number list. If we now print the squared numbers list, we see in the console the items from the numbers list are all squared. Let me clear the console and now let's do the same with the list comprehension. I start off with creating a list called squared numbers list. After the equal sign I add square brackets. Here we can now add the same logic like in the for loop. I start with the expression number multiplied by number for each item called number in the iterable list numbers. Here we go, we created our first list comprehension. As you can see, it is space saving and this example is easy to read. Now let's print it to the console to prove we have the same result. Et voila! As I said in the intro, we are now going through some examples. The squared numbers from the basic section was the first beginner-friendly example. Now we will go through another one, creating a list of even numbers in a range of numbers from 1 to 11. For this we create an empty list called evens, and then we start again using a for loop to filter out the even numbers. The line is for number in range 1 to 11, while number is the item and the range is the iterable. The expression in the loop is now if num modular operator 2 equals 0, then append this number to the evens list. And that's how we can filter all evens in the for loop. Let's check the result by printing the evens list to the console. As we can see, the list now contains all even numbers 2, 4, 6, 8 and 10. Perfect. Now let's do the same by using the list comprehension. For this we create a list called evens underscore list and in the squared brackets we can implement the same logic. We start with the expression num for item, num in iterable range 1 to 11 and then we add the if condition if num modular operator 2 equals 0. And that's it. In the first tries this might be a bit unhandy, but you will get into it by using it. Now let's print the result of this to the console and check that we get the same output. As you can see, we created two matching lists. Before we get into the immediate examples, I want to thank you for watching my content. I would really appreciate to get some feedback in the comments from you, so I can get a feeling if my content was helpful for you. The first intermediate example is about flattening a list of lists. The list we want to iterate through is called nested list and it contains 3 sublists. One with 1 and 2, one with 3, 4 and 5 and one with 6. For the for loop we create an empty list called flattened list. This time we use 2 for loops, one run for the sublists and one run for the parent list. So the first loop goes for the item sublist in iterable nested list. then the second loop for item num in iterable sublist. And here we add the expression append the num to the flattened list. By this we add every number in every list to the new list flattened list. Let's see if it worked by printing it to the console. As you can see, it worked. Now clear the console and try achieving this by the list comprehension version. But before I show you the way, it might be a good time to stop the video and try it by yourself. I hope you got it if you tried it. If not, here's the solution. In the squared brackets we add the expression num for the item sublist in the iterable nested underscore list, and then go one step deeper by using the same list as expression for the item num in the iterable sublist. I think this is super handy and your code benefits from the faster execution to the optimization. As last step here, let's compare the two outputs again. As you see, they match. I clear the console and we can get over to the second intermediate example. Here I want to show you how to filter and transform a list of strings. The filter or if condition is that I only want words in my new list that are shorter than 5 letters. As base I created a sentence list with 3 short sentences. These are hello world, Python is fun and keep it short. For the loop version I create an empty list called short underscore words, and then I run again 2 for loops. One to split the sentences into its words by running the loop for sentence in sentences. Inside here I save all words to a list by splitting the sentences, and then I run in the second loop over every word in the words list. Here I add a if condition that checks every word length, and if it's under 5 letters I append the word to the list short underscore words. Now when we print it, we see the new list only contains the words is, fun, keep and it, because they are shorter than 5 letters. Now let's do the same with list comprehension. I start by creating the list called short word list. And now is a good point again to stop the video and try to convert it by yourself. This will now a bit more complex. Please take the time after and try to understand what I did. I add the expression word for the item sentence in the iterable sentences, what equals the first loop, and then we run this loop as expression for the item word in the iterable sentence, which I directly split. And then I run the if condition if the length of the word is smaller than 5. Only then the word will be added to the list. To be honest, we are now at an example where I'm not sure if I would do the comprehension for the speed boost or the loop for the better readability. And so should you also decide what fits your coding style better. To close this example, we see we got the same output in the comparison. Now let's get over to the more advanced examples. Here, the first one is more a dictionary comprehension. I just added to show you what you also can do with comprehension. The example is about creating a dictionary from 2 lists. First, we have the keys list with the item name, age and city. And second, we have the values list with Alice, Dirty and New York. Now we want to combine these two so we have matching values for the keys. For the loop, I create an empty dictionary called person underscore data. Then I run a loop for item I with the range function for the len of the list keys. This helps me to run through the keys list by using the index for the items and not the item itself. Therefore, I can start matching the keys and the values by its index and add it to the person underscore data dictionary. You might be thinking this was not so advanced, and you're right, but trust me, dictionary comprehension can be very complex super fast when you get into it. Now let's see the output. As you see, everything is matching fine. Clear the console and let's get into the comprehension version. For this I create a dictionary called person underscore data underscore list. As earlier, it is a good point to stop the video and try it by yourself. In the curly brackets, we add key colon value as expression for key comma value as item in the iterable, where we use the zip function for the keys and the values to match them together. As you notice, for this example, we need a help function from Python called zip that does the matching for us. It's not possible to do it in another default way. At least, let's compare the outputs before we finish the example. As you see, it worked. Let's clear the console and jump in the last example of this video. I first create a matrix with 2 sublists from 1 to 3 and 4 to 6, which is our base list. In the transposed result we have 3 sublists, which represents the items of the index of the original matrices. For the loop variation I create an empty list called result. And then I can directly go into the loop. Here we run again for every index I in the range of the length of the matrix at index 0, which is here for 3 runs. Or in other words, the loop runs 3 times through. Inside the outer loop we create an empty temp row list, where we store the items of the sublist for the index I. Then we run a loop over every row in the matrix and append the row of the index to the temp_row list. This loop runs 2 times because we have 2 rows in the matrix, which represents the sublists. After filling the temp_row list, we can append it to the result list. And that's it. This is how we can achieve a matrix transposition by using for loops. Let's print and see the output of this. As you can see, we now get 3 sublists with every index matching them from the original matrix in a new list. Wow, this was heavy work and it is hard to explain. Now, one more last time. Let's see how the list comprehension version of that looks. I create a new list called result_list, and it is again a good point to stop the video and try it out by yourself. Inside the brackets we create a new list. And inside this list we use the row element at the index for the row in the matrix and then loop it for every index in the range of the length of the matrix at index 0. And that's it. But to be honest, even it is a way shorter than the loop version, I would recommend using the loop version cause the readability is not as well. If you have unexperienced people in your team, they might get overrun by this. We are almost done. Just let's compare the outputs again and then do a recap of the learning nuggets. List comprehension code executes faster, which is good for your overall program performance. In many cases, list comprehension improves the readability of your code. Don't hesitate to use loops if the logic becomes too complex for the comprehension. Alright everyone, I have shown you how list comprehension can make your Python code cleaner and more efficient. Can anyone think of situations where list comprehension might streamline your project? Let's hear some ideas. Remember, they are a powerful tool, but like any tool they have their ideal use case. If things get too complex with the list comprehension, don't hesitate to switch to a for loop for better readability. Happy coding! See you, bye!